So for our 1-1 notes, we're going to look at some basic definitions. And these symbols and exactly what I'm writing up here, guys, are very important for the remainder of your geometry career. Okay, so really try to write things down exactly as I have them. If I write a capital letter, make sure you're really writing a capital letter, and so on and so forth. So these are our basic definitions to get us started. All right, so a point, right? Just like we would normally think, if you just put a point on your paper, a point is used as a start or end to something. Used as a start or end to something. Right? We also need to know that points are labeled with capital letters. So if I was just trying to symbolize point A, I'd have a dot with maybe a capital A above it. Point B would be something like that. Okay, with a capital B above it. So then moving on and integrating that with our next few definitions. In a line, you need to think that any 2 points determine a line, right? If you and your friend are standing next to you, you can put a straight line between the two of you. And even if your line or your friend goes out to the parking lot and you're farther away from them, still you make you're the 2 points. You can put a straight line between the two of you. So a line, again, would be any 2 points, which I'm just going to abbreviate points, determine a line. And you also need to know that it extends infinitely far in both directions. Extends infinitely far in both directions. So for instance, now if I were to take 2 points, right, and I put a line through it, now how we show that something extends infinitely far in both directions are arrows. Okay, so you must have arrows on the end of those. A line goes on forever and ever. So now let's talk about labeling a line. Okay, so if I came down here, had those arrows, put 2 points on here, we'll call them capital C and capital N, point C and point N. And if I asked you to name that line, well, one, just because you see the arrows, you would need to tell me it's a line. And then to name it, you would either call it line capital CN, which means it has that symbol over it, or capital NC. When you're reading those, you would call that line CN or line NC. Either one, it doesn't matter. That would still give you the same picture. Okay, moving on to array. So array begins at a point called an endpoint. So it begins at a point called the endpoint, which I'm just abbreviating, and extends infinitely far in one direction only. Extends infinitely far in one direction. All right, so if I start at the end point, I'll give it point A. Let me just give you that as your picture. We'll actually move A down here, okay, just so it's not up in that writing. Doesn't matter where you put those, right, because those are just points A and B. If I ask you to name that ray, the thing you need to know about a ray is it begins at the end point. So you must start with letter A. Okay, notice in a line, you could change the order. It was CN above or NC. But down here, you've got to start with the end point. So you have to start with A. You're saying that arrow travels through B, and the symbol must always go to the right. Okay, it looks like a ray and it's above it. I would call that ray AB. Okay, so just another for instance then, what if we drew this picture? Put point P here, point N here. Again, the only way you can name this one is to start with the end point. So it would be ray NP, because again, we said that symbol has to go to the right. One more, if I were to draw this picture, put a couple of points on here, H and C. Then again, if I asked you what this ray is called, you would have to name it ray C because the endpoint is first, ray CH. Okay, so the endpoint has to be first. All right, a segment then is part of a line, right? It's only part of a line. So by definition, part of a line. So then let's go ahead and just go back and practice what we were doing with a line. Okay, so if I were to draw this picture, points A and B, I hope you're going to tell me that this is line, right? Line AB, and you would label it this way. Or I hope you would tell me that it's line BA. Again, lines can be labeled either direction. But if I now were to just pick up this part from this point to this point under it, from A to B, so they stop at endpoints, that's what makes up a segment. All right, and the segment can be either direction again. You don't really have to put the points above it. That's a little more detailed than it needs to be, so you could just draw that. Okay, some people may go as far as putting these points on, and that's what I'm telling you guys that I'm not requiring you guys to do. So I'm going to take that back away, just for ease of writing and for typing. When you see us write it, you're going to just see us put that. Okay, so segment AB, or it can be segment BA. All right, an angle. Angle is one that seems to be challenging for students. So let's do a bunch of practice here, guys, and see if we can get this down for you. All right. I like to think of an angle as kind of like you're trying to map out some directions for somebody. If a student is trying to figure out an angle, I like to try to describe it as like a roadmap from one point to another point to another point. So let's go with basic. Let's just draw one angle in this picture. All right. And so first thing to know, let's put some points on here for communication. Let's put point A, point B, point C. Now the thing to know about an angle is that an angle always has a vertex. Okay, so this, in this picture, our vertex sorry, that's not showing up. It's on the edge. Let's do this. Write it that way. All right, so that vertex, guys, is right here at letter B, at point B. It's just basically wherever it bends, and you've recognize angles from thinking about like the corner of a room, right? There's a 90-degree angle there. It's where two surfaces come together if we were thinking about the room. So the vertex is where two, what are these things? Well, these would be rays, right? If you went from ray BA and ray BC and you're putting them together, where those two rays come together is basically your vertex. Now let's say I was trying to enclose, let's say I put a number 1 in here, and I say, let's enclose number 1, that angle. So what we're trying to talk about, guys, is this angle right here. Okay, from this wall that would be ray ABA, and the other wall, which would be ray BC. Okay, the way we're putting it in here. So if I want to enclose that angle, basically if I wanted you to draw this exact same thing and I asked you not to look at it, I asked you to put your pen on a paper and draw from A to B to C. You would draw exactly the same thing. If you knew where A, B, and C were, and you were to draw from A to B to C, you would enclose angle 1. So angles can always be labeled with 3 letters, and you need this angle symbol. Okay, looks like a less than sign. So you would say this is angle capital A, B, C. They have to be capital because of the points. So that's telling you to travel from A to B to C. Likewise, I could get that same angle if I traveled from C to B to A. So you should be starting to notice the pattern that the vertex point, that point B, always has to be in the middle. Now you're safe always labeling an angle with 3 letters. However, you can sometimes label an angle with only 1 letter. In this case, where there's only 1 angle in the entire picture, I can also call this angle B, where that vertex lies. So those are the 3 ways I can label this angle. If there's more than 1 angle in the picture, you got to be careful with the 1 letter. Okay, so let's draw another picture to try to explain that. So if we draw some segments here, another one, get some points in here, point C, point B. Now you got to understand in geometry, guys, we have to be able to draw this so you can read the picture. So when you see a point B like this, you got to understand that point B is right there at that dot. Okay, it's right there at that dot. I just can't label it right on top of that because you wouldn't be able to read the picture. So you got to get used to that a little bit. I'm putting point A here, point E here, and point D is going to be right there. I can't put it on top, so again, I could write it anywhere. I'm just putting it to the side, so you need to understand that. Now, if I ask you to enclose angle 1, okay, there's angle 1. So again, what I'm really trying to enclose is there to there. It's almost like the corner of a room. Okay, that's not a 90-degree angle, but it is an angle. That's the angle we want to talk about. All right, well, I could travel from angle, let's say, any letters that would enclose that. So I could go from B to C, or sorry, to D, and then to A. That would enclose that and make it now connect from blue to blue. So angle BDA, which means it should be obvious that I can reverse that and make it angle ADB. Right? Change colors since I'm doing a video so that hopefully you can now see this. Now other options. Notice you've got this other point out here, point C. All right, so would I get the same picture, guys, as far as enclosing that angle 1 if I were to go from C to D to A? Of course, because now notice if I go from the green to the green, it still encloses that angle 1. So angle CDA works. I could also call it then the reverse, angle ADC. And then the last one is the debate, okay? So we want to know, we said we could always think about if it's possible to call it just that middle vertex. So notice the vertex D of that angle is in the middle of each of these. So what I want to know for a minute is, can I call this angle D? And the answer is absolutely no. And here's the reason why. Remember, D is this point. It's sitting right here. Well, from here, guys, I see at least 4 angles. There's one over here. There's one over here. There's one down here. And there's one here. Okay, there are still more. So just saying D doesn't tell me which side you want me to enclose. Okay, so this would be a big no. Remember, you're always safe to call an angle with 3 letters, and sometimes you may call an angle with 1 letter. Going back to over here, this one worked because there was only 1 angle in the picture, that angle. So let's go on and do a little practice with this angle stuff here and see if we can help you. So this is exactly what it's going to say when we do our homework. Okay, so for this example, go ahead and write down these directions for yourself. Let's say give the number or numbers. Give the number or numbers. My board likes to do that once in a while, so I'm not quite sure, but try to use just my index finger. Seems to make it work better in the corner. So give the number or numbers that make the angle. Actually, I should say, let's say make up each angle. All right, so here we go. First one. We'll do 4 different parts. Let's say I wanted you to tell me what number or numbers make up angle WAX. Again, remember these are capital letters. Okay, so what that means to me, if I'm looking at this real quick, is I'm going to trace from W to A to X. And I like to think of it as going to the vertex and saying, I'm going to kind of connect to show my angle. I'm going to connect from the purplish blue wall to the other purplish blue wall. Okay, what did I enclose? I enclosed the number 1. And I'll use different colors to help us out. So B, if I did angle WAY. All right, well, if I enclose and I go from W to A to Y, and again, I'll just keep coming out here and I go from the pink wall to the pink wall, well, I now enclosed 1 and 2. And the way I want you to put that so it will help us later is I want you to write 1 plus 2. Okay, because if 1 had an angle measurement of, say, 30 degrees and 2 was 40 degrees, and I asked you for WAY, I hope you would tell me the whole thing would be 30 plus 40, which would be 70 degrees. Okay, so that's why I want you to get in the habit of putting the plus in here. So call it 1 plus 2. Let's go with a different color again. All right, so on C, let's do angle ZAY. This brings up a good point. Since I'm writing it, let's go ahead and talk about it. Let's please get in the habit of crossing our Z's. Okay, in upper level math, that's what we do, so that it doesn't look like any of your guys' number 2s. Okay, so cross your Z. Anyway, angle ZAY. Here we go. Z to A to Y. Hopefully you're seeing from the blue wall to the blue wall, we're enclosing angle 3. Okay, so those could both be called interchangeably. Angle ZAY is also angle 3 in that picture. And last but not least, if we were to go for D, angle ZAW, and I went from Z to A to W, well, notice from purple to purple, I've now enclosed all of them. So you should be telling me 1 plus 2 plus 3. All right, 3 more definitions. Okay, hang in there. 3 more definitions that are super important in geometry. First one's collinear, and if you just, I like to break down that word. If you think about the word co, like we coexist, meaning together, and linear, meaning line, okay, hopefully that's going to mean to you like points on a line, and they coexist. So any number of points are collinear if they lie on the same line, okay? Any number of points are collinear if they lie on the same line. Okay, so I'll give you a moment to write that. Any number of points are collinear if they lie on the same line. And then realize that any 2 points are always collinear. Now think about that. Just randomly 2 points. It could be you and your friend. Okay? You and your friend, I can always draw a line between you. If you add another friend, if you guys are in a straight line, of course you're collinear. But as soon as that 1/3 friend goes out somewhere else, okay, they are not, you guys all three are not collinear any longer. Okay, so you need to know any 2 points are always collinear. We like to do always, sometimes, never questions in geometry. So if I say how many number of points are always collinear, your answer is going to be 2. Now, what if I said any 3 points are blank collinear? Hopefully you're going to say any 3 points are sometimes collinear, because you and 2 other friends could line up, but not necessarily. Okay, a plane, important definition. A plane, I'm not talking about the kind that's flying through the sky. Okay, we're not talking about that. We're talking about a flat surface. Okay, so a plane is any flat surface that extends infinitely far in all directions. All right, so think about a flat surface. If you're in the classroom, any flat surface that extends, so if you could imagine that it extends infinitely far, the wall would be a plane. The ceiling, the floor, the desk you're sitting at, the top of it, the top of the teacher's desk. Any of those things would be a plane. Now in geometry, as far as how they're drawn, okay, the only thing we can draw is something that looks like that. That's going to represent a plane when you see it in your homework. Okay, and then you just need to know that it extends infinitely far in all directions. And then lastly, coplanar. Well, if you break down that word again, coexisting, and then planar, we just went over plane. So any number of points are coplanar. Coplanar if they lie on the same plane. Okay, and the other thing you should know, like the other example, is that any 3 points, that's kind of the maximum, any 3 points are always coplanar. Okay, any 3 points are always coplanar. If you go above 3, and I said like any 4 points are blank coplanar, it would be sometimes coplanar. Okay, not always.